Okay, guys, so I'm presented with a situation here, all right, for my math class. And the situation reads: just before 6 p.m., students entered the classroom to find Mr. Fies dead of an apparent homicide. Everyone said they saw it coming. At 6, the temperature of the body is 80 degrees, while at 7 p.m. it was 75 degrees. It took a while for the campus police to get through the party. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? Okay, so we're going to be looking for the time of death. So we're going to use Newton's law of cooling, which is T equals T ambient, which is the room temperature, plus T of the object, which is the temperature of the object, minus the room temperature times e raised to the kt, and k stands for the decay coefficient times the t, time of death, which is what we're looking for. All right, so before we do that, let's go over what we have here. It says at 6 the temperature of the body is 80 degrees. Okay, so it started out at 80 degrees, so what we know of, right? Okay, and then at 7 it was 75. So we have to find the the decay coefficient for this Newton's law of cooling uh excuse me, equation before we do anything else. All right, so for that we're going to use 1 second. Okay, for this we're going to use the same equation, right? Just different variables. Okay, so UT is going to be the temperature, okay, that the body was found, okay, which is going to be 75, okay. Tm, which is the ambient, is going to be, like I said before, the room temperature, which is 70, plus, open parentheses, the temperature of the object, all right, which the original temperature of the object, which was 80 when it was located, minus the room temperature, which is 70, times e raised to the kt, and t is going to be 1. Okay, guys? And then now we're going to solve the equation for k. So what we do is we do 75 minus 70, which gives us 5, okay, equals 80 minus 70 is going to give me 10, e raised to the k times 1. All right, we want ek1 by itself, so we're going to divide by 10 on both sides. 10 cancels out over here. All right, so we're left with 5 over 10, which reduces down to 1/2, equals e raised to the k1. All right, and so we want the k1 by itself. So what we're going to do is we're going to take the natural logarithm, which is ln 1/2 equals ln e k1. All right, guys. So this cancels out, leaving us with ln 1/2 equals k times 1. And we want k by itself, so again what we're going to do is divide by 1. So the 1's cancel out over here, leaving us with ln 1/2 over 1 equals k. Alright, and then we put this into our calculator right here. Alright, once we put that into our calculator, we see that k is approximately negative 0.693. Alright, guys, so we just found the decay coefficient. So this decay coefficient, we're going to use it for this Newton's law of cooling to find the time of death. Alright, guys? Alright. Alright. So let me rewrite the equation again. It's going to be T equals T ambient plus the T object minus T ambient close parentheses times e raised to negative kt. Alright guys, so now let's fill in what we know. We know that the room temperature is 70 degrees. Alright? So 70 times e. Okay. We also know that the decay coefficient, which is negative 0.693 times t. T is the time, which we're looking for, the time of death. All right. The temperature of the object that is the original temperature. So we're going to use the natural body temperature of a human being, which is 98.6. And for right here, the T, big T, that's the temperature that where it was found at, which is going to be 75. All right. So we do the whole process over again, that like we did last time. 75 minus 70 gives me 5. All right. Equals 98.6 minus 70 gives me 28.6 times e raised to the negative 0.693 times t. Alright, so we want to get this by itself, so what we're going to do is divide 28.6 times e to the negative 0.693 t by 28.6. Same thing over here, 5 divided by 28.6. Alright, that cancels this out, leaving us with 5 over 28.6 equals e to the negative 0.693 times t. Alright, and to get rid of the e, we want to get the natural logarithm. So what we use is going to be ln 528.6, alright, equals ln e raised to the negative 0.693 times t. Alright, so this cancels out right here, leaving us with ln 5 over 28.6 equals negative 0.693 times t. Alright, so we want t by itself. So what we're going to do is we're going to divide by 0.693, negative 0.693, alright guys, on both sides. So this cancels out over here, giving us t by itself. And if we put ln 5 over 28.6 over negative 0.693, we get approximately t equals approximately 2.52. Alright guys, so that's how long it's been since Mr. Fies has been deceased. Alright, okay, and so we go back up here to 75. Okay, the time that Mr. Fies was found while his body was at 75 degrees was at 7 p.m. Alright, and so to do that, to find the time of death, we're just going to subtract 2.52 from 7 p.m. Alright, so it's going to be 7 o'clock minus 2:52. Alright, okay, so we borrow from the 7, gives us 6, 9, 10, gives us 8 right here, 4, and 4. So Mr. Fies was killed at approximately 4:48 p.m. Okay, guys, that's how we found out. and that's how we find out the time of death of Mr. Fies. All right, guys. Hope this really helped. All right, and good luck.